Okay, in this video we'll show you how we can import the DXF file that was sent through and then pass that through into the machining module. So I've started the PartMaster 2D CAD software here, and we'll import that DXF drawing. Okay, so this is it, and it's in inches, and we'll leave these defaults as they are. Okay, so as you can see, there's quite a few bits of pieces there that we don't need. What we'll do is we'll go into Edit, Delete All, and we'll get rid of any points, any text, any hatching, and any dimensions. Okay, so that just leaves us with a bit of basic geometry. Now, as you can see, there's things missing here. But that's not a problem, because we can use the intersect and clip routine to get these lines back. So what I'll do first is I'll just delete out some of these lines that we don't want here. Okay, so if I use the intersect and use the item clip items, so what this does is it clips things back to the positions where they would intersect. Okay, so let's just delete out these odd lines. So there's quite a few extra lines as part of this DXF file, as you can see. The other thing is that within the DXF file there's some settings which are making the layers go to this yellow color. So if I just change that, and we'll make it black. There we are. Okay, so if this is the shape that we need to machine, we'd probably want to mirror image that. So to do that, we go to mirror in the X plane, and we just, okay, so that's just mirror image that. So to take that through into the machining module, we need to create a profile, which is a series of linked line and arc segments, and we also need to set up our datum position. So to do that, we go into NC, and we choose from the vertical toolbar on the left, set NC datum. So that will be the ZX0 for our part, and we'll create a profile. So we'll basically start here, and because the shape is not closed, I need to give it an endpoint. So as you can see, it's traced around to this position here, but there's a decision to be made, maybe because there's multiple elements there. So if we just choose which ones we want to go to. Okay, so that's that profile been created. It's drawn in a thicker line style so we can see it, but that won't have any effect on the actual machining. So let's save that away, and I'll call that wheel 1. Okay, so now we go into the turning software. So we can enter a program ID or a part number. We can set our tool change and our home positions if we need to. So when we're in the machining software, we can define our tools as being approaching from the rear or approaching from the front. So to set up the tools, we go to the Define Tool dialog box, and it starts off with a standard CNMG tip, and if we want to approach from the front, we can leave these as they are. If we're approaching from the rear on a standard lathe, then we can set them here. The tip radius we'll set to 0.015, which is 0.4 millimeters. And if we wanted that tool to be able to cut into that little groove there, we could either machine that separately with a grooving tool, or if we set the included angle, which is this angle here, to a smaller amount. So if we set that to a 55-degree tip, which is a DNMG, then that tool now should go into that dimple without needing an extra machining. Okay, the cut depth here specifies the size that we're going to be using, and it sets the tip size at the same time, but we can change that to be whatever we want. So that's defined a tool, so it's got it in the tooling definitions window here. If we put multiple tools into here, then we can automatically save that tool file away and get it reloaded each time we start a new job. So you only need to define your tools once. To select that tool for use, we choose the select tool dialog box, and this is where we can set the spindle speed and the feed rate, and we can either output the feed rate as feed per minute or as feed per rev. If we need to use coolant, then we can switch that on here. So maybe with this tool we'd want to face off the front of the job, so to do that we use the facing command, and basically this needs us to set the cycle limits, which would be the maximum in Z and X that we want the tool to move to. So this first position here would be a position outside of the stock. The end position could be 0, and we don't need it to use a profile. Oops. So okay, and that's just showing us the tool center line. If we animate the tool, okay, that's just doing a simple facing off operation on there. Now we can use that same tool and do a roughing operation. So we're turning towards the chuck. So again, we need to give it the limits of where we want the tool to work. So this will be the extents that the tool will work between. You can enter your own values here if you like, but the limiting profile here will be the profile that we created, so it won't go past that. Okay, so you can see how it's gone past there, but we can stop it doing that by saying that we don't want it to enter any undercuts. We could also, if we wanted to, set our cut depth to be, say, 4, and if we just run that again, so we can take multiple cuts there. Okay, so if we don't want it to cut round to the back, we can set the Z finishing to a smaller value. Okay, so if that was a roughing cut, we could use the same tool for a finishing pass, or if you wanted to select a different tool, we could use the finishing tool. But you'll notice how that tool, because of the tool geometry, has been able to fit inside that dimple there. So we have various ways of looking at the tool, just the tool center line, or we can animate the tool. Okay, so if that's what we wanted to do with that, that would be okay. If we did want to part it off, well, then we could just define a parting off tool, which is a grooving type tool, and we'll give it 0.1 thickness and 0.25 cut depth. Select that tool for use, set the spindle speed and the feed rate, and then use the part off command. So what this does is it looks at the extent of the part and produces the parting off to suit that. And at the end we might want to send that tool back to its home position, so we use the go to command, send the tool to its home position, and we're going to move in the Z axis first. So it rapids across in Z and then goes to the tool change position in X. So depending on how we've got the setup of the machine, we can choose the dimensions for the tool change position here. Okay, so having got to that stage, we can post-process that, and we can use the lathe with whichever post-processor we want, depending on your machine and controller. And then what that does is it produces the G-code file here, which then can be taken down onto the machine tool. If you needed to, you could also run, if you have the lathe standard module, you can run the 3D simulation. So that produces a file which is passed through to the simulation module. We can leave all these defaults as they are, we don't need to worry about those, and just go straight to simulate. So that's now preparing the simulator. So that's the stock material, this is our tool, and then there's simple video controls over here. Okay, so we can set up different parameters to do this. For instance, we could get the facing operation to plunge down past the center line so it gets rid of the pip, and we can also put in extra cuts to get rid of the slim slither that's left here. But that's basically how the software works.